Choose your fighter.
Hello, Assalamualaikum. Now, we will introduce to you what is compound A until compound H. Now, the first one, what is compound A? Let's go and check it out. Oh look, there's a paper there. Let's go. Yes, compound A is cis-but-2-ene. Now, how do I know that cis-but-2-ene is compound A? Well, it is stated that compound A is polar. Hence, cis-but-2-ene is polar. Why? Because cis-but-2-ene, they have two metal group on the same side of the double bond. Hence, it creates and dipole moment exists in this compound rather than trans-but-2-ene. So that's why I know that cis-but-2-ene is compound A. Okay guys, compound A, which is cis-but-2-ene, it has 4 structural isomers. Let's figure out. The first structural isomer is 2-methyl-propane. The second one is cyclobutane. The third one is 1-methyl-cyclopropane. And the last one, definitely cis-but-1-ene. Okay guys, now we have done with the structural isomers. What about stereo isomers, guys? Hey, not too close. Why? Oh, I forgot to tell you. You want to know about the stereo isomer, right? For compound A. Okay, does it exist? Yes, definitely, because compound A is cis-but-2-ene. Now, the stereo isomer for compound A is trans-but-2-ene. Of course, if the cis form exists, of course, the trans form is also exists. So what's the difference? As you can see here, trans-but-2-ene, it has 2 metal group that attach to the different side of the double bond. Okay, now we have done with structural isomers. We also done with stereo isomers. Okay, now what's the last isomer? Yes, optical isomer. Does optical isomer exist in this compound? Nah, it doesn't exist. Hence, if there is no optical isomer, there is no Fischer projection and no 3D notation involved. Alright, that's all for compound A. Let's move on with compound B.
Hi there, and I will explain to you about the compound B. So I already found the compound B. Compound B is trans-but-2-ene, as you can see here. So why compound B is trans-but-2-ene? So in this question, it's already stated that compound B is a non-polar. So why trans-but-2-ene is a non-polar? Trans-but-2-ene is a non-polar because in it, there is a dipole moment of 2 between the CCH3 bonds are equal and opposite, and hence, they exactly cancel out each other. So this is why trans-but-2-ene is a non-polar. So for trans-but-2-ene, we have 4 structural isomers. So first structural isomer is 2-methyl-propanol, as you can see. And the next structural isomer, we have cyclobutane. Next structural isomer is 1-methyl-cyclopropane. And then lastly is but-1-ene. So for stereo isomer, we only have 1 stereo isomer for trans-but-2-ene, which is cis-but-2-ene. So for the optical isomer, trans-but-2-ene did not have it. So I think that's all for compound B. Move on to compound C.
Okay, next, what is compound C? Compound C that I have found is ethanol. So this is the structure of ethanol. So how I determine this kind of structure? Because the statement said that when compound A and compound B undergo a ozonolysis reaction, so it will give a single product, which is compound C. So this is the reaction occur. And the last one is I have found 2 structural isomers that involve in compound C, which is the first one is the ethanol and ethylene oxide. So that's all for compound C.
Okay, so now for the compound D. So compound D is ethanoic acid. Generally, oxidation of an aldehyde will produce carboxylic acid. So in this case, of course, oxidation of ethanol will produce or give the ethanoic acid, that is compound D.
now we continue with compound number 5, which is compound E. So what is compound E? Here, compound E is butan 2,3-diol. So how I know that butan 2,3-diol is compound E? Well, it is stated that compound E, which is cis-but-2-ene, undergoes reaction with CaMnO4 to produce this compound, which is oxidation process with cis compound will produce a meso compound with A, and it undergoes an oxidation process. For compound E, there are 5 structural isomers, which are: the first one is 2-methyl-butan 1,2-diol, cyclobutan 1,2-diol, cyclobutan 1,3-diol, butan 1,3-diol, and the last one is butan 1,2-diol. Intermediate compound that exists in this compound is this ethanol. Ethanol exists during oxidation process. Alright, next we continue with stereo isomer. Compound E has 2 stereo isomers, which are: the first one is L-butan 2,3-diol with its 3D notation and Fischer projection, and the next one is D-butan 2,3-diol, and here is the 3D notation and Fischer projection. Next we continue with compound F. Bye bye.
Hi there! We meet again. So here I will explain to you about compound F. So I have found compound F is D-butan 2,3-diol, as you can see here. So why I found this compound F is D-butan 2,3-diol? Because in this question already stated that compound B react with potassium permanganate to produce racemate mixture, which is compound F and G. So here is the equation for it. And then next, for the structural isomer of compound F has 7 structural isomers. So first structural isomer is second, the third one, then fourth, fifth, sixth, and the last one. So for the compound F, it also have optical isomer, which is 2 optical isomer. I will show you in 3D notation and Fischer projection. So this is for the first one, and then the second one. So I think that is all for compound F. So move to compound G, because compound G is related to compound F.
Next, what is compound G? Compound G that I have found is L-butan 2,3-diol. So how I determine this kind of structure? Because the statement said that when compound B undergo a reaction with the cold neutral potassium permanganate, it will give a compound G. So this is the reaction occur. Next, I have found 7 structural isomers that involve in compound G, which is the first one is the butan 1,2-diol, butan 1,3-diol, butan 2,2-diol, butan 1,4-diol, and 2-methylpropane 1,2-diol, cyclobutane 1,2-diol, and cyclobutane 1,3-diol. Next, the last one is the optical isomers that I have found is 2, which is the first one is the D-butan 2,3-diol, and the last one is the L-butan 2,3-diol. So that's all for compound G.
Okay, for now, it is compound H. So compound H is meso 2,3-dibromobutane. So generally, bromination in CCl4 of transalkene compound will give the meso-dibromo compound. So in this case, of course, bromination in CCl4 of trans-but-2-ene will give the meso 2,3-dibromobutane. But this is inconsistent with a carbocation intermediate because free rotation of alkane would allow all possible 2,3-dibromobutane products form either isomer of but-2-ene. So here is the 3D notation of the meso 2,3-dibromobutane, and here is the Fischer projection of meso 2,3-dibromobutane. That's all from us. Thank you.